Okay, so yes.
When is our next week?
On Friday, the block period. Okay, so that way you don't have time issue. Sometimes like people need extra time. But you guys should be finished on time. Number 3. I would do it differently than they do it. I would do it in a Y perspective, but the work is same amount because you had to convert to Y, and you're gonna get same answer of 0.729. B is the same way. This I have to do it in terms of X, top minus bottom, and C is the rotation above X axis, so that's a washer. This should be very easy, but the hardest part is defining the intersection here. Intersection is 0.902. For those of you guys first time take AP exam, Khrushchev, Jing and Raphael, this is different in science class because science class use significant figure, and I don't know how to use significant figure even though I'm a chemistry major. So in math it's much easier to use 3 decimal places. So always keep your answer in 3 decimal places. Khrushchev, make sure. Don't do 0.9, 0.902. Jing same way on the exam. 3 decimal places. Raphael 3 decimal places. Everybody should know already 3 decimal places, just except you guys. And that's 2003. That's a few years after I graduated. That's when I was in college, graduated. Well, no, I take another year to graduate because that's pretty dumb. Yeah, I was pretty dumb. I failed a couple classes.
Did you say dumb or dumb?
Dumb.
Oh, okay.
I cannot pass this lab class. It took me like 3 tries.
Were you distracted with that lesbian you were in love with?
No, that was sophomore year. Something me and Corbin have in common.
You don't have to say that, Mr. She's gone. No, I told her to leave. No, you don't think about it. I'm glad you had my life.
Okay, any question about this? Khrushchev, Jin, Raphael, you guys doing okay?
Did you do one? He did.
All right. So this is an FRQ practice. That's enough practice for area and volumes. For the setup parts, do you still need help? I know like some people says they still need help. I'll go over a couple questions if you want to. Yes.
For the very last question, would they accept 156 pi, or do you have to do just pi?
3 decimal places.
Ooh.
And pi. So, or you can do 156.038 times pi and keep it at 3 decimal places.
Yeah, that's true.
You don't have to multiply by pi. You can, yeah, that's legit answer. So.
Yeah, everybody's been doing that.
Okay, let's go to area and volume. Does anybody need help with setup or no? Okay, so which one?
Can you go over H for the first question?
Isabel, is it okay if I go over H? Okay. So I have no idea what is that. So let me go to area and volume.
You can't see it.
Hold on, just let me get there. I don't know. Is this one or no? Is this one?
Oh, we can't see it, Mr. Ye.
Oh, sorry. Quick time. Okay, is this one?
Yeah.
So first of all, I will. It's the same one, right? Because I have two different versions. I don't know if this is the right version.
Yep, yeah, that's the right one.
Okay, x minus 2. The graph is gonna shift right to. So it's gonna be like something like this, and it's all the way to 11. So it's gonna be here, and that's gonna be here. Now it's x equal to -3, so x equal to -3 is gonna be right here. That's the axis rotation. And what I'm gonna do is I'm gonna do a big. This is dy, right? Is that okay? And this is this. Is this okay? Now I'll draw another arrow here just because all I need is visualize the distance. I figure out the questions. So in this case, this will be a dy. Obviously, it's between 0 to 3 because we stop at 3. We stop taking the girl at 3. And this is going to be washer. Now, washer has a big R. The big R is the red line. So it's going to be this one plus that. So will be 14. Big R of y is equal to 14. Why is 14? Because it's the distance from axis rotation to x-axis. And it went from x-axis to the boundary, and x-axis to the y-axis to the boundary is 11 plus 3.
Which one are you doing right now?
X equal to -3. Right? Am I doing right? Okay, so I'm doing H because Corbin says she needs help with H.
Okay, so
Y is gonna be 3 plus the function, because this bar is 3, right? Then the function is from x-axis to there, so that's gonna be 3 plus the function. So will be 3 plus, I don't know what is the function, so y equal to root x minus 2, y squared plus 2 equal to x. So it'll be y squared plus 2. Now I just need to, don't forget pi, 0 to 3, and it's going to be 14 squared minus 3 plus, make sure you parentheses, dy. Is that okay? Isabel can ask me another question if you want. G. Okay. Y equal to 8. So we're gonna do the same thing. So I'm gonna erase this part. I'm gonna erase this part, and I'm gonna go back to figure out this. So the same graph. So the same graph from here to here, and it's gonna be what? 8. Y equal to 8 is right here, and that's axis of rotation. Now, you're gonna draw lines from it has to be from axis rotation to the boundaries. So it's gonna go in from here to all the way here, and it doesn't matter, it's always the same. And from here to here, the blue line is gonna be from here to here. However, I'm gonna draw a black line here. It's gonna be from here to here. That represents the functions, because the function is usually from axis to the curve. I think that's the hardest part for people to understand. The function equal to the axis to the curve. So in this particular case, I will figure out that this one is gonna be dx. I will figure out it's between 2 to 11. I'll figure out this is a washer. And I'll figure out what's a big R of x. In this case, is gonna be 8. Is that okay? Because that's the red line. And the small r of x is equal to the red, which is I color code this, minus the black, which is the function. The function is gonna be x minus 2. So therefore, it's integration. Don't forget pi. Other people, I think last year somebody forget pi. I had to mark half off on every single one. Make sure including the pi except the cross sections. And it's between 2 to 11. And this is 8 squared minus 8 minus x minus 2 squared dx. Is this okay? Because the problem is people don't get is this part. This part is a function. It's not rotating there. It's rotating the blue line, not the black line. The black line is a function. Isabel, does that make sense? Do you need me to go over one more setup or no?
No, okay.
Good? Okay, so just knowing that the function that they give it to you is always from the axis to the boundaries. But the way you draw is usually from the axis rotation to the boundary, sometimes might be a different orientation. And if you need it on this side, I would draw like 2 arrows, like this is a 3 plus something. So that way you can visualize that what happened. Okay, so I'm not going over the rest. I'm going to talk about shell method, which is you're going to have on the test. So why do they call it shell? Like, why do they call it shell? Yeah. I'm ready. Okay, so the rotation slightly different. So let me remind you, disk is based on a circular disk. So it's area of a circle. Wesley, pay attention. Disk is area of a circle. So it's going to be integration of r of x dx from a to b pi square, or from pi r square of y dy from c to d. So because they might have a different boundary, right? So we're going to have to say c to d. So this is the area of a circle. So area of circle. Now the shell is the area of shell. No, it's a washer, sorry. A washer. So area is a washer, so this is a washer method. So washer method, so we just review. Is based on pi and this r square of x minus r square of y dy, because there is a to b, there's a bigger radius and there's smaller radius. They subtract each other, so based on this, we are basing finding the area of this, right? Yeah. And this one is going to be pi from c to d, r square of y minus r square of y d. Oh, sorry, this is x. My fault. This I write it too fast. This is x, and this is x. This is y. This is in term y. So one's area of circle, one's area of washer. Now for shell method, it's a little bit different. Shell method, I believe, is more based on circumference rather than area. If I have a single dot, let's just say if I have single dot like here, like I'm gonna have this single dot right here, and I'm rotating around y-axis. So it's gonna form what kind of shape? If I have a single dot rotating around y-axis, it's gonna give a circle. But what we're finding If you're rotating around y-axis, what are we finding? Are we finding area of a circle? Circumference, right? Does that make sense? What if you have a line that is rotating around y-axis? What kind of shape am I going to get? A ring.
Frisbee.
Not a frisbee, no. If I have a line, like if I have this is my axis, and this is my marker. If I rotate it around, it's gonna be a circle with a height, right? So it's called shell, and that's what kind of shell method. Does that make sense? So basically, this shell between the bottled water and this marker is rotating across the y-axis. So if you see that they're parallel to rotation, and like the Deskin washer is perpendicular, so this rotation is this way. Now, if it's this way, you can figure out the ring. The ring is based on how far the radius. The radius is from the water bottle to the marker. That's the radius, right? And also the height of the marker is rotating. So this is kind of like a ring, but it has height on it, so we're gonna call shell method. I don't know, in physics class, like you're supposed to have a solid tube and those hollow tube, and they have the same density. Which one's gonna rotate faster? Do you guys did that experiment?
The hollow one, right?
Last year, yeah.
Hollow one's gonna be faster, or the solid one's gonna be faster?
I think it's the hollow.
Because the mass is like on the outside.
I don't remember. Anthony?
I believe you.
Okay, so what we are thinking about is the hollow one. The hollow one is a shell. So let's just say if I have this one here, we're gonna give you a question. So the questions here is gonna be based on volume of shell method. So volume of shell. Hollow one's faster.
No, that's solid.
Solid one, why?
Out.
Volume of a shell method is equate to, well, 2 pi. It's not pi, but it's 2 pi. But why is 2 pi? 2 pi r, circumference, right? Because circumference equal to 2 pi r. It's not based on pi r squared now. It's based on 2 pi r. Okay? And it's based on, so we're going to talk about vertical rotation. So vertical rotation is based on 2 pi from A to B of the px and h of x dx. So what I'm trying to say is this. If I have a function like this,
What do you mean PX?
px, I'm going to address that in a second. P is more the way I think about it, it's a radius from the center axis to the outside rotation. This is represent the height of the function. Represent the height of the function. So it's more like it's a radius and the height. The height is based on the function, right? The height is based on the function. So I'm gonna write down height here. And this is the radius. So I'm just gonna give you a question for you to see. So let's just say if I have y equal to x minus x cubed. Obviously, you can factor out x. That's gonna be 1 minus x squared. So this graph is gonna be something like this. but we only restricted from 0 to 1. We only restricted 0 to 1. So we're going to say restrict between 0 to 1 and rotate around around y-axis. Now, do you realize if I rotate in y-axis, it's hard for me to use. It's hard for me to use the washer. Why is it hard to use a washer? Why is it hard to use a washer? They're the same curve. And also, why is the second thing that's hard? What's the second reason that's hard?
Area under, it's just the line.
No. Remember, if I would do it this way, right? If I do it this way, I need a dy. Is it possible for me to solve for x here? Look at the function.
Ooh.
It cannot get y by it cannot get x by itself, right? It's not possible. So technically, you need it to use shell method. So the shell method basically is really easy. Here it's going to be 2 pi times, well, the rotation is based on 0 to 1. So it's going to be 0 to 1, right? Let's start with the radius. What's the radius? Well, radius is just x, because from here to here is the x, right? And from here to here is the function, which is, we're going to call this h of x. So this x times h of x, which is the x minus x cubed dx. Voila, you're done.
How did you know the radius is x again?
Because the radius, remember, this is a ring that I'm rotating, right? This is the x value. And you're going to base on the height, then you plug in x into the h of x, which is this. So this is the radius. This is the height.
How is that the radius though?
So imagine that if you have,
Wait. So we're not looking at a solid, right? Are
we are looking at a solid. This gonna be like some type of shape like this, and it's rotating.
Well, yeah, but is it? But are we including the stuff under the curve?
Yeah. So this gonna
Okay,
rotate. If you rotate this, it's gonna form a ring based on this bar. But this problem is this whole thing is rotating, so it's gonna be like some type of like this.
Infinite rings to make that solid.
Infinite shell. Infinite shell. We are just talking about one shell right now. If a one shell, let's just say it's 0.5, right? What is my radius? 0.5, right?
Okay.
And I plug in 0.5 into the function, I get a height.
Okay.
And then that's rotating because we're looking at the circumference.
And then you do 2 pi
Because the circumference.
And then because the interval is from 0 to 1, it then makes the infinite amount of.
Yeah, and then you integral together, it's just adding all the pieces together. So you're adding this piece, you're adding this piece, you're adding this piece, you're adding this piece, but they're all different shell, different height, different radius. The radius is from here is x. Super easy, it's x. Not always. But we're gonna talk about why that's not always.
Well, it's either going to be x or y.
And this one just gonna give you a 4 pi over 15. You can do the integration on that part. I'm not gonna worry about that part. Yeah, I'm not worried about the integration. Yeah.
So why is the radius? The radius is x.
Can somebody explain
Because
better than I can?
basically, Alvin, what you're doing is you're making an infinite amount of. So basically,
It's all the x values.
yeah. So whereas before the radius would have been.
That doesn't work.
What?
Use the actual marker. It doesn't work. Professor Sorrow's gonna
Because
explain
what
to
you're
you.
doing is you're taking the integral of x. So what you have to do is you have to look at, okay, so from 0 to 1, you're taking every single value from 0 to 1. So you're taking the value of this ring that goes around like that, this ring that goes around like this ring that goes around like this, and so on. So you're taking all of those rings, which slowly build up a solid, but instead of composing it with how we did it before, where we're taking the radius this way, and we would be, or this way, we're taking and rotating it just like that. We're rotating just the line each individually.
That makes a lot more sense.
I say exact same thing, I swear.
It's the visualization.
But it's just because he's white. I'm just saying.
Crazy.
Huh? What'd you say?
We're doing it basically.
Really? Do I do a better job this year though? All right. So how about this? The way that we're gonna do this, we're gonna pose a challenge. This challenge is gonna be like y equal to x squared plus 1, y equal to 0, x equal to 0, and x equal to 1. So this is gonna be bounded. It's rotating around y-axis. Okay, rotating around y-axis. Now, some people, if you prefer to be washer, that's fine. Use washer. This question can be done with the washer and shell, but one of them is easier. I don't know which one, but one of them is a lot easier. I wonder. I don't know.
Does he know? I think the radius.
The radius is not always x. Be careful, because I'm gonna give you propose the next one. This one is. Next one is not. Oh, you cannot get used to always x.
Trying to like figure out how could it not just
If an axis rotation is at y x equal to 2. So learning how to set up. Don't use hand calculation. Just type in the what you call it, the decimals.
Why is it not one?
You should get the same answer. If you try both ways using calculator come out, you should get the same answer. But one way is easier than the other way. So this is called shell method preferred, because you probably prefer shell method here. But washer is going to give you the exact same answer, except the problem is you have to do more than one integrals. You had to do disk and washer at the same time. How much time I have? That's enough.
10 minutes.
Okay, thank you.
I feel like why isn't this called like an onion method? I feel like that would make it a lot clearer what you're talking about.
Yeah, like shows everybody like.
Because with an onion Okay, wow. Very independent.
What you guys get?
I got 6 pi/4. 3 pi/2.
3/2. But did you? Can you do a washer and desk together?
I mean, yeah, but I don't want to.
I said please.
Oh, I thought you said to do the. I thought you said to do the free method.
No, you can do so. But I want to just tell you like how hard to do desk and washer at the same time. Because you had to break up to two different one. This one's gonna be a desk from 0 to 1. From 1 to 2 is gonna be a washer. Because this part is gonna be this way, right? This part is gonna be a desk, and this part is gonna be a washer. So you have to do both. You have to do integration between 0 to 1 and then 1 to 2. But I'm gonna do shell here first. What will be the shell here? Between what? Between what? What boundary between we'll do? 0 and 1. What do we put in the front? 2 pi. And this one's gonna be x times x squared plus 1 dx. Wow, so much easier. Now let's do it in the washer if you want. So first of all, we do a disk. So that's gonna be 1 squared dy between 0 to 1. Does that make sense? That's the bottom part.
You're doing this to death?
Yeah, this part is a disk.
That's just for the first part.
Right? Plus the second part, which is pi, between 1 to 2. The outer radius is going to be 1 square.
Square root of y-1.
And the second one is going to be square root y minus 1. Square dy. And guess what? If you do this correctly, you're going to get 3/2.
Because from 0 to 1, it's still. But the value's not there. Like, it's just. It's
Oh,
just, it's just
dy,
square.
All right. Because you're going to do a disk and washer at the same time, you might just do one shell. Knock it up, both out of the park. Okay. Now, this last question is a little bit different. It's off axis of shell. So we're going to write down off axis of shell. Okay, so it's going to be y equal to x cubed plus x plus 1. And you can use it, you can use decimals to graph that. Now we are rotating around x is equal to 2. Rotating around x equal to 2. Be careful. There's two things you have to care for. There's two things you have to care for. It's because of y equal to 1, it's cut off the graph to like leave the bottom part hollow. So that's the part you have to pay attention to. There's 2 traps. The setting 1 and 2. 2 traps. Two traps.
Because the y is yellow.
How much time we have?
You can do this with the.
No, it has to be shell.
But that's the same way that we do like
It has to be short because you cannot solve for x. Because if you do a dy, it has to be a washer, then we cannot solve for y. We cannot solve for in terms of y. So it's not possible to use a washer. You can use calculator to graph that graph, but I'll give you that graph. That graph something like 1, 2, 3, like this. It's cut off by those 3 things, and this is the rotation.
Yeah. I'm just trying to figure it. I was like, X minus 2 doesn't work.
Well, we know 2 pi is outside.
Radius still x.
So what would the other be?
The radius is x. I don't know. Is it?
Oh. I forgot about the X.
Is the radius x?
Right.
It's just a bound.
I'm gonna draw a bar to help you. I'm gonna draw this bar right here. We're rotating based on that bar.
Yeah. No, you end up doing -1, so you have that. Because you're not going all the way down to 0. You're getting rid of 1 for the height.
That's the second trap Ethan just mentioned. First trap is that radius.
Right.
No, you explained it right. I don't know if you did it right, but you explained it right.
Because look, you're not counting the very bottom. So you have x cubed plus x plus 1, but then the bottom, you're not including the bottom, the first bit. So it's just x cubed plus x. I'm glad you drew it out because I didn't realize that it was above. Well, I didn't realize it was above x equals 1. I thought it was below x equals 1. So I wanted to.
Why not? He didn't say no, he said maybe. -1. Wait, what if the radius?
So what is the radius here?
3. What if it's 3? Is it -1?
Raphael, what's the radius? He's the quietest one, so I'm gonna ask him.
What's it?
What? You don't know? Jing, what do you think? No? Anybody's brave enough to say it? Yes, Ethan?
2 minus x.
Why do you think it's 2 minus x?
Well, for one, Jordan didn't say that earlier, but also it's because you have
You
to
take Jordan's credit? You could
Yeah,
have said
no,
Jordan
we
says
we
it.
both got to that. We both did that. But I was just saying Jordan said it earlier and you did not.
Okay, imagine that this is this here is, imagine this, right? Imagine this is 0.5, right? But what is the radius from here to here?
1.5.
It's 1.5, so it's 2 minus x, right?
And then
Now the second, this is the first trap, this is a radius. This is a radius. The second trap is the height. The height, what Ethan mentioned already, is the function -1. Because the +1, I had the -1 because you subtract, because the base on this height right here is not based on the height from the function to all the way to the bottom. Now, today you just need to learn to set up. The answer is going to give it to you. And tomorrow we're going to talk about arc length. And we finished this.
Oh shit, Patty's not here.
No, I think she's watching the video. Yeah, there's one viewer. It's Maddie, probably. What's up, Maddie? Aiden says hi.